Every large-scale AI model requires a specific physical footprint. Right now, the rapid expansion of this technology is colliding with a physical reality. We are running out of server racks to plug into. On April 9, 2026, Meta moved to secure its long-term future, signing a $21 billion agreement with CoreWeave. This contract locks in AI computing capacity through the end of 2032. The scale of this hoarding is massive. Only 24 hours after Meta's deal, Anthropic signed its own multi-billion-dollar production scale agreement with the same provider. 9 of the top 10 AI labs are now locked into similar long-term contracts. This leaves the world's most advanced data centers heavily rationed, with almost no remaining capacity for new players. By April 13th, analysts reacted to the raw math of structural compute scarcity. They raised price targets based on physical capacity, prioritizing hardware ownership over speculative software potential. The traditional, centralized cloud is effectively full. For AI to continue its expansion, it must find a way to function outside these massive terrestrial centers. One powerful solution to this severe bottleneck moves the processing from massive industrial centers directly into your pocket. In April 2026, Google DeepMind released the Gemma 4 family. Designed specifically for edge deployment, they run entirely without a cloud connection. This is achieved through quantization, compressing the neural network to operate under 1.5 gigabytes of RAM. Despite their size, these models handle complex agentic reasoning, calling tools and analyzing local data natively on a laptop or Raspberry Pi. By April 13th, developers were already demonstrating multimodal builds that guarantee zero data exfiltration. Every calculation happens locally on the user's hardware. This shift empowers independent developers and highly regulated industries to bypass massive data center gatekeepers, democratizing access to frontier-level AI. To escape the terrestrial bottleneck, the most remote bypass for AI infrastructure moves the hardware entirely off-planet. Kepler Communications recently utilized a SpaceX Falcon 9 to launch 10 optical relay satellites, establishing a new kind of infrastructure in low Earth orbit. This constellation contains roughly 40 Nvidia Orin Edge GPUs, all interconnected by laser communications to form a high-speed orbital compute web. On April 13th, Sophia Space began testing its Orbital data center software directly on these in-orbit nodes, processing data in the vacuum of space. By running AI models where the data is collected, like weather sensors or Earth observation cameras, the system avoids the latency of sending raw files down to Earth for processing. This represents a physical escape from terrestrial bottlenecks. When the ground-based cloud is full, the next logical step is to move the processing to the source of the data. The current hardware shortage is forcing AI development to split into 3 distinct physical layers. We see heavily rationed server farms for the largest labs, hyper-localized processors in our pockets, and newly established GPU clusters orbiting the planet. The victor of the next decade's AI arms race will be the player who secures the physical space to plug their machines in.